All right, so welcome to today's class. We'll be looking at sets of numbers, and you can see the objectives there on your screen. Okay, so we are going to define and explain and understand what the natural numbers are. You can see these ones there. We are going to look at what whole numbers are. Okay, we're going to take a look at the integers, the rational numbers, irrational numbers, the real numbers. So these ones are very important, okay, because they're the ones that will be coming in your most of your assessments. And then for the complex numbers, we're just going to look at them, but we're not going to go into details about complex numbers. All right, so as you already know, okay, I know you know the definition of a set. Okay, so a set is a collection of well-defined objects, right? So we have different sets, okay? We can have a set of fruits, okay, a set of cars, a set of shoes, and the like. But for this class, we are going to be looking at the sets of numbers, okay? So the numbers that you use each and every day, they are grouped into different categories. And those are the categories that we're going to be looking at today and explaining what they mean. All right, so we start with the natural numbers there. So I've written this down here on my board so that you can also be reading through with me. All right, so we start with the natural numbers. Okay, start with the natural numbers. So the natural numbers are the simplest to know. So what are the natural numbers? Okay, so the natural numbers are numbers that we use to count. So they are also called counting numbers. So those are the natural numbers. Okay, so any number that you can use to count something, it's called a natural number. Okay, so these natural numbers will be represented by this symbol of n here. So you write an n like this, and then here just make sure that there are two lines like that. This here, this symbol here will represent the natural numbers. Okay, so the natural numbers, since they are counting numbers, you are going to start at 1. Okay, when you start counting something, you don't start at 0, right? You don't start at 0. You start at 1, 2, 3. So the natural numbers are going to start at 1, and then they are going to be increasing by 1 until whatever number that you're going to reach, where you're going to stop your counting. Okay, so the natural numbers are the counting numbers, and they start from 1, and then they'll be increasing by 1 just like that. So you can see um, the example there that I've put there. Okay, 1, 2, 3, 4, 5, 6. Okay, and then I've put these to my 3 dots here. So I've put dot, dot, and dot. So these ones here mean that the numbers continue to increase, okay, until a certain point where you're going to stop your counting. Okay, so natural numbers are counting numbers. So some important things to know about natural numbers is that they cannot be fractions, okay, because we don't use fractions to count. So we can't say 1 and then 1.5. No, okay, it's just 1, 2. If you put the fraction there, it means you're not counting, but you're measuring. Okay, you're measuring something. That's when you put the fraction. So a good an example of the application of the natural numbers is when we are counting maybe the patients that are admitted in a certain ward at the hospital, or even the number of students that have been admitted in the January intake. Okay, we are going to use the natural numbers. So natural numbers are counting numbers. Okay, so any questions there? Right, so I'll move to the next set of numbers, which are whole numbers. Okay, so I know we've been hearing about whole numbers from our primary school, secondary school, but we don't really know them by their definition, right? So whole numbers are simply the natural numbers, including a 0. Okay, so the natural numbers, we said they start at 1, 2, 3, and then they continue increasing like that, right? So to these natural numbers, when you include a 0 like this, you start at 0, then it means the set now that you have formed is actually a set of what? Whole numbers like that. Okay, so whole numbers are just obtained, what I was writing there, are just obtained by including 0 in the set of what? Natural numbers. Okay, so an example of where we use the whole numbers, it will be maybe the number of doses that are remaining in a pharmacy. So there will be at some point where the dosage is just 0 because all the medicine has been given out. Okay, so you can see here I was writing it can be 0. So the number of doses remaining in the pharmacy can actually be 0. when all the medicine has been given out. Okay. And then another example is the number of patients waiting for consultation. Okay, the number of patients waiting for consultation at the hospital. They will reach a time where a doctor has actually attended to everyone. And the number of patients waiting for consultation, they will be what? 0. Okay, but there can be at times where there are 2, 3, and the like. Okay, so this is also an example, okay, of using the what? The whole numbers. Okay, so those are basically the whole numbers. You get the natural numbers, you include a 0 there, then you get the whole numbers. So the whole numbers will be represented by this symbol here. So it's a W, and then this first part here, it should be 2 lines like this. Then we are going to say this symbol here is the symbol for the what? For the whole numbers. Right, so let's move on to talk about integers now. Okay, so integers, how can I put it in the simplest way? So you saw the set of whole numbers, right? So to that set of whole numbers, we just add replicas of the numbers that are coming at 0, but we include a negative in front. So we first had natural numbers, which were 1, 2, 3, and so on. These were natural numbers. Then when we included the 0, we got what? Whole numbers. So now, to this set here, if now I include a -3, -2, -1 like that, you've seen I've just gotten these numbers here and then taken them this side and then added a negative in front. Okay. So if now I have such a set, okay, that is coming from whatever is coming from here, and then -3, -2, -1, 0, 1, 2, 3, and then it goes wherever it's going. This set now is going to be called as a set of integers. So you've seen how they are building up, right? Okay, very nice. So a set of integers will just consist whole numbers and their negative equivalents. So that's how we can say it in a proper definition. So this is the definition that I've written there. Okay, integers consist of whole numbers and their negative equivalents. So meaning whatever I can see this side now, I just put a negative in front, then I get the integers. Okay. So integers are very interesting numbers. I know back in secondary school, you were mostly encountering them on the number line. Okay, so when you draw something like a number line, you were putting 0 and then you start with the negative numbers like this. Okay, and then on the other side, you also put the positive numbers. So these numbers that we are putting on the number line, that's what we call as integers. Okay, so it's also very important to note that these integers, they can never be fractions and they can never be decimal numbers. Okay, so if I write 1.2, this 1.2 here can never be an integer. Okay, it can never also be a natural number, and it also can't be a whole number because it's a decimal number. Okay, and also fractions like 5/3. This one here is not an integer. Okay, so integers just consist of the whole numbers and their negative equivalents. So there are no point something 1/something in the in the integers. No. Okay, so now these same integers here can actually be divided into 2 parts. Okay, can actually be divided. Should I say 3 or 2? Okay, let me say 3. They can be divided into 3 parts. Okay, so these ones here, you can see 1 going these sides. They are all positive. Okay, if I start at -1 going this side, they will be all negative. Okay, and then this is 0 here will just remain alone. It will be neutral. Okay, so the integers can be divided into positive integers, negative integers, and 0. Okay, I hope you've heard that. Positive integers, negative integers, and 0. Those are the integers. Okay, so now all the integers together, they have a symbol of Z, and then this guy here has 2 lines like this. This is the symbol for the integers. So now when you're just specifically talking about the positive integers, you're going to write this Z, but with a plus like that. Okay, so maybe I should write it here. So Z and then with a plus. So this would mean that this is a set of positive integers. And then one thing that you should know is that positive integers are actually equal to the what? To the natural numbers, because they'll just start at 1 and then they'll be increasing by 1 like that. So when you say positive integers, it's the same as we say natural numbers. Okay? I hope you've seen that. And then also we have the negative integers, which will be represented by z with the minus like that. Okay? Right. And then 0, we just represent it by 0 because it's 0. Okay, so examples where we use the integers, we can use them in the temperature readings or temperature changes, okay? For example, minus 3 degrees Celsius, 0 degrees Celsius, and even 5 degrees what? Celsius. Okay, so those are examples where you can use them. So we move to the next one. So if you have any question, just stop me and then I'll be able to explain. Okay, so now we talk about another very interesting set of numbers, which we call as rational numbers. Okay, so rational numbers, this word here, rational, should not scare you. Okay, it should not intimidate you. By rational numbers, they just mean numbers that can be represented as a fraction. That's all. Okay, when you hear rational numbers, in your head, you just say fraction. That's all. Okay, so rational numbers are numbers that can be represented as a what? As a fraction. Okay, so 2 over 5. This will be a rational number. Okay, and then these rational numbers can also be represented as a non-repeating decimal number. For example, 2.1. This also is a rational number because I can actually convert this 2.1 to a fraction by saying, okay, this is 2.1. So how many decimal places does it have? It has 1. So I'll just write this without the point. It will be 21. And then I'll say over 1. And then how many decimal places do I have? I only have 1. So I add 1 0 like that. If it was 2.22, to convert this into a fraction, I'll write whatever is here without the point, and then I'll say 1. Okay, and then the number of 0 that I'll be adding to this one will depend on the number of decimal places that I have. So here I have 1, 2. So I'll put 2 zeros like this. Okay, so any non-repeating decimal number is also a rational number. Okay, but by definition, you can simply say the rational numbers, these are numbers that can be represented as a what? As a fraction. Okay, as a fraction of what? Of 2 integers. Okay, so maybe you can also add that clarification there where the denominator should never be 0. So for example, 5 over 0. This one here is not a rational number. Okay, because the denominator there should never be 0. Because when you divide something by 0, you're going to get math error on your calculator. So you should try. Just divide any number by 0, you're going to get math error. Okay, or you're just going to get undefined. Okay, the calculator is going to write undefined. All right. So by set builder notation, we can represent this set of rational numbers as a set of all numbers, as a set of all x's, such that this x is equals to a over b, where a and b are actually integers, and this b, which is below here, should never be equals to what? To 0. So those are the rational numbers. All right, so the symbol for the rational numbers, you can see it there. It's just a Q, like that. And then you just draw a second line like that. Okay, so that's the symbol for the rational numbers. Okay, so we now move to the brother to the rational numbers, or the sibling to the rational numbers. So the other numbers now are what we call as irrational numbers. So to the rational, we have just added this IR in front, so that have now become irrational. So IR, okay, also means not. So by guesswork, these numbers are not rational numbers. You've seen, right? So this IR in front here, it means not. So by guesswork, we can say irrational numbers are not rational numbers. And that's exactly what they are. Okay, they are numbers that cannot be expressed in the form of A over B or in form of a fraction, because this is a fraction. So these irrational numbers cannot be expressed in the form A over B. So meaning they are not rational. Okay, but in a smart way, in math, we don't say not rational numbers, we say irrational numbers. Okay, it's just to make it sound good. Okay, but it's actually the same. So the irrational numbers are numbers that cannot be expressed as a fraction of 2 integers. Okay, so for example, later on we'll talk about the surds. Okay, so all surds are irrational numbers. Okay, so by surds, we just simply means a number that does not have a perfect square root. So for example, if I write square root of 4, if you punch this on your calculator, okay, or if you know it in your head, the square root of 4 is 2. Okay, the square root of 9 is 3. The square root of 16 is 4. Okay, so these numbers you can see have a perfect square root. So they are not irrational numbers, these ones here. Okay, but now the irrational numbers, they won't have a perfect square root. So for example, root of 2. If you punch root of 2 on your calculator, okay, root of 2 on my calculator, it's giving me 1.41421356. You can see here the numbers are just changing randomly. You don't know which number is coming next. Okay. So if you have such a number that has 1 point, and then they are non-repeating decimal numbers that are coming, okay, and they are endless, we're going to call that as a irrational number. Okay, another example is the root of 5. If you punch root of 5 on your calculator, you're going to get 2.236067977. So you should try on your calculator. Okay, you're going to get exactly this. So you see that the decimal places that I'm getting, okay, they're non-repeating and they will be endless. Okay, so if you have such a number, just know that it's an irrational number. All right, another example is pi. I know you are used to 22 over 7. Okay, so when you do 22 over 7 in your calculator, you're going to get 3.14. This is what most of you were using. Okay, but this number actually continues 2857143 and so on. So it's an irrational number. Even E, okay, it's also an irrational number. So E, it's 2 point something. I've forgotten the points there. Okay, 2.7 something. So it's also an irrational number. Okay, so just have it in mind. Okay, that an irrational number is a number that will have non-repeating endless decimal points. Okay, non-repeating endless decimal points. All right, so any questions, guys, on what we've discussed so far? Any questions that you have? Okay, I hope you guys are actually understanding this, okay? Because it will be very vital for the rest of the topics that you're going to do in math. Okay, to be very vital. You have to know the sets of numbers and then you start using them in different topics. Okay, so let's move to real numbers. Okay, so real numbers, these ones are very important, I must emphasize. And most of the questions that you're going to be having, they are going to be on the real numbers. Okay, so real numbers is just a combination of all the numbers that we've talked about before we reach real numbers. It's a combination of that. Okay, so we get the natural numbers, all numbers, integers, and then we talk about rational, irrational. We put them together, then we get the real numbers. Okay, so real numbers includes all rational and irrational numbers. Okay, they represent all they represent all points on the real number line. Okay, so that real number line like this, I have 0, 1, 2, maybe -1, -2. Okay, we said if we are talking about the integers, then we're just going to be picking these individuals here like this, okay, without picking the numbers that are in between the 0 and 1, maybe 1 and 2 and the like. But when you talk about the real numbers, we're picking everything on this number line, okay? So even the number that comes after these two, maybe 2.0 something, it's also a real number, okay? 2.5, it's a real number. Okay, 1.5, it's a real number. 0.7, it's a real number. So all the numbers on this real line here, okay, are what we call as real numbers. So the real numbers start from -infinity all the way to positive infinity. Okay, so now what is infinite? Okay, what is infinite? Some student asked me, what is infinite? Okay, so infinity is actually not a number, but it's just used, okay, to show that um, the numbers go on endlessly. Okay, they don't end. You can continue counting from today until the day you die, until the day Jesus will come. You can be still counting. The numbers won't end. Okay, so as mathematicians, they are always trying to be smart. Okay, they created this casimbo at infinity. So when they say infinity, they just mean the numbers go on endlessly. They don't end. Okay, they don't end. So we'll be representing by that casimbo, like it's an 8. Okay, and then we drop it down. Okay, so there's positive infinity if you're going to the positive sides, and then there's also minus infinity if you're going to the what? The negative side. All right, so now what is important about the real numbers is that since they contain all the points on the real number line, right? It will be very important for us to represent these real numbers in what we call as intervals. Okay, so intervals would just be like the limitations, okay, of how many real numbers are we going to consider. Okay, but actually, in any interval that you can have, they are uncountable numbers. Okay, so if, for example, I write this interval from 0 to 1, the numbers that are between 0 and 1, you can never count them. They are endless. There are a lot of numbers. There are infinity numbers there. Okay, we can start counting from today until the day Jesus will come. We won't finish counting them. Just the numbers that are between 0 and 1. So these real numbers will be represented by what we call as the intervals. Okay, so the intervals will just be showing us the starting point, okay, and the end point of a range of values that we are considering. Okay, so this is what I was writing there. So I was saying intervals on the real line. Okay, so let A and B be the real numbers where A is less than B, or in other words, let's say A is the lower limit and then B is the upper limit. So when you're talking about intervals, you're going to be experiencing two types of brackets. Okay, and I want you guys to really understand this. We're going to be representing two types of brackets. So there's a square bracket, which is like this. Okay, or it can be like that. This here is called a square bracket. Okay, and then there are curved brackets, which are like this. Okay, so both of these brackets, they have different meanings. Okay, so I can write A here as my starting point for this interval, and then I say comma, B as my end point for that interval. Even here, I can write the same. Okay, so now when I'm using squared brackets like this, it simply means the number at the end here, I'm actually counting it as part of this interval. Okay, so it means this interval here is from A to B, including the same A and the B, because they are what? Square brackets there. But if I consider these ones here, where they're curved brackets, okay, this interval will contain all the numbers between A and B, but it won't contain the A itself and also the B itself. Okay, so the way I've written this interval here, it's called as an open interval. Okay, why is it called an open interval? Because the numbers at the end are not actually part of this interval. Okay, they're not part of this interval. And then this one here, it has square brackets like that. So meaning that the numbers at the end, they're actually part of the interval. So this one is called as the closed interval. Okay, it's called as the closed interval. This one is the open. Okay, so when now you are representing these intervals on a number line. Okay, these ones that have the curved brackets. Okay, the endpoints will be drawing a circle, and then we're going to be shading it like this. Okay, so if there's a bracket like this, a square bracket like that, okay, on the number line, we're going to be indicating it as a shaded circle like that. Okay, and then if there's a curved bracket like this, on the number line, we're going to be indicating it as a what? As an open circle like that. So you can see I haven't shaded that circle, but this one I shaded it because this is a square. Okay, so for example, if I represent this on the number lines, for example, this is a number line here. I have A somewhere and then B. So to represent this interval, I'll draw a line between A and B. Okay, and then since they are curved, square brackets there, I'll shade on A like this, and I also shade on B like that. So meaning that B and A are actually part of this interval. For this one, it will be A there and then B. So on A, I'll draw an open circle. On B, I'll draw an open circle. Then I'll draw a line like that. So meaning that this interval, everything between A and B is included, but the A and B, they're not included themselves. Okay, so this one is called a closed interval. This one is called an open interval. Okay, and then now we have what we call as the half closed and half open intervals. Okay, so if I'm starting with a square brackets like this, then I put my A, then comma B, and then I end with a curved brackets like this. Okay, so this one here, it includes, this one does not include. So I'm going to call this as a half closed. Okay, a half closed. And then when it is in this form, if I start with a curved and then comma, a B and then a square like this one here is going to be called as a half open. Okay, half open what? Interval. All right, and then these intervals also, we can represent them using what? Inequalities. Okay, we can represent them using inequalities. So remember the inequalities that we have. We have the less than, we have also less than or equal to, and then we have the greater than, we also have greater than or what? Or equal to. So this less than or equal to and the greater than or equal to are equivalent to these guys here. Okay, so let me write them somewhere here. Okay, so if I have this guy here, okay, this guy here, it's equivalent to less than or equal to. If I have this guy here, okay, uh, no, this one should be greater than or equal to. Made a mistake there. So this one is greater than or equal to, okay? And then this guy here will be the same as less than or equal to, okay? On these inequalities there. And then if I have this curved like this here will be the same as the greater than. And then if I have this curved like this one will be the same as the less than. Okay, so I need you to understand this notation, guys, okay? Because once you understand the notation, whatever question that they can bring, you'll be able to pull out the correct notation. So meaning you are going to shade the correct region. Okay. And once you shade the correct region, you're going to answer the question what? Correctly. Okay. So I've talked about the intervals. I've talked about the meaning of the brackets. Okay. I've talked about the meaning of the inequalities there. Okay. So meaning that this guy that we can write like this, we can also write like that. Okay, we can also write like that. And then this guy, we can also write like that. That guy, we can also write like that. That guy, we can also write like that. All right, so that is all about the interval notation. What is remaining now is how to use it. Okay, so any questions there? Any questions that you have before we look at an example question? All right, so I hope you're following. So let's try to, okay, the first, I wanted to say, let's go to this example here, but let's talk about the complex numbers first of all. Okay, so what are the complex numbers? Okay, complex numbers, by the word itself, complex. So it's something that is complex, right? So the complex numbers, they consist of two parts. So there's the real part and the imaginary part. So when you combine the real part with the imaginary, then you become you you come up with something which is complex, right? Okay. So a complex number is a number that consists of the real part and the imaginary part. So imaginary numbers are actually not real numbers. They're just imagined that they are there, but they actually don't exist. So mathematicians are actually crazy people. They are very mad. Okay, because why do they start just imagining things and then they put them in the notes for us to read? For what for? They're just making our life difficult. Okay, so complex numbers to be a combination of the real part and the imaginary part. So the imaginary part is always um, followed by I, like that. Okay, it's always followed by I. So I means imaginary. Okay, meaning a number is not real. They are just imagining that it's there, but it's not real. Okay, that's what the I means. Okay, so now I in value, this I. Okay, the I is the same as the root of -1. Okay, so in some books that you can read, you see that they say I squared is actually equals to -1. Okay, I squared is actually equals to -1. Okay, so how do I get this? They just square this side. So there's a square there. And then here there's a root. If they square, this square and the root will cancel out. So I just remain with the -1. Okay, but don't worry about this anyway. I'll just explain the imaginary part. So now, if I get a real number and then I add or subtract the imaginary number, then I have a complex number. So for example, this one here. So I'll say I have the real part, let me say 5, and then I say plus 5i. Okay, so you can see this one is just a real number, a normal number that we know. But this one here is just an imaginary number. So I combine what I can see and what I don't see. I get the what? The complex number. Okay, so these are complex numbers there. Okay, and then here there's an important note that you should take note of. So I was saying a complex number does not show one part explicitly, meaning it does not show the real part, or it does not show the imaginary part, then we have to take the other part as 0. So what this actually tells us is that all the numbers that we deal with are actually what? Complex numbers. Okay. And that is the reason why complex numbers is the biggest set of all the numbers that we can have. Okay. So I'll show you a question after this. It's the biggest um, set of numbers that we can have. So all the numbers that actually you use every day, they have a complex, they have an imaginary part, but that imaginary part is just 0. So if the imaginary part is 0, then the number becomes a real number. But it's also a complex number, but the imaginary part is just 0. So you can get mad, imagine. But anyway, okay, so I was explaining about the complex numbers. I was saying you have the real part, okay, which is this part here, and then we have the imaginary part there with the I. Okay, so it becomes um, a complex there. Right, and then I was saying either of these two can actually be 0. Okay, so if I just write a number 5, it means that the imaginary part with the I is actually 0. So it's like 0i. So we just don't write this part here. Okay, and then again, if I just write the imaginary part, maybe I say 2i, it means that the real part is actually 0. So it's like this. Okay, and this one here makes the complex numbers to the to be the biggest set of all the numbers that we have. Okay, so now let's move here and talk about the hierarchy of these numbers. Okay, hierarchy of these numbers. So this hierarchy of um, numbers, we're going to represent it with the notation of a subset. Okay, we're going to represent it with the notation of a subset. So remember what a subset is, eh? So for example, if I have a set A, and then this set has 1, 2, 3, and then 4 as its members. Okay, and then from this set A, I get another set, let's say C, or let me say just D. And then in this set, I put 1 and 2. Okay, so this would mean that this set D here is actually a subset of this, because all the members that I can see in set D, they're actually present in what? In set A. Okay, all the members that I can see in set D, they're actually present in what? In set A. So we are going to say D is a subset. So this here means subset. Okay, is a subset of A. D is a subset of A, because all the numbers that are in D, they're actually what? In A. So we are going to say it's a subset. All right, so now when you talk about the set of numbers, okay, we said we had the natural numbers. We then went on to talk about the whole numbers, okay? After the whole numbers, we talked about the integers, okay? After the integers, we talked about the irrational numbers. I mean rational numbers, okay? And then um, after the rational numbers, we talked about the what? Who can remember? What numbers did you talk about after the irrational numbers? The rational numbers, I mean. Actually said the answer. Okay, so the symbol for rational numbers is not R, but it's this Q here, like this. Okay, so now what's the symbol for the the irrational numbers? Okay, so for the irrational numbers, we're just going to write I like this, and then R like that. So that this here represents the irrational numbers. And then from the irrational numbers, we talked about the real numbers like this. Okay. Then from the real numbers, we talked about the complex numbers. Okay. So actually, these numbers or these types of numbers, they are subsets of each other. Okay. So remember, we said to these natural numbers, if I add a zero, then I get the whole numbers, right? So meaning that all the natural numbers are going to be a part of the whole numbers. So the whole numbers is a subset of what? Is a subset of the whole numbers like this. Okay. And then to these whole numbers, when we add the negative equivalents, we're going to get the integers. So meaning all the whole numbers are actually part of the integers. So we're going to say the whole numbers, they are a subset of the what? The integers like this. Okay. And then the integers will be a subset of the rational numbers, just like that. Okay. And then here, I cannot say these um, rational numbers are a subset of the irrational. No. So the irrational are going to be on their own. Okay. And then here I'm going to have that the rational numbers are actually a subset of the real numbers. And then the real numbers are a subset of the what? Of the complex numbers. So this is the hierarchy. Okay. So the biggest set of numbers that you have is the set of complex numbers. And then followed by the real numbers, followed by the rational numbers, followed by the integers, followed by the whole numbers, and then followed by the what? The natural numbers. And then the irrational numbers, these like to be lonely. So they are just on their own like that. They don't want any noise from these other neighbors. Okay? They're just on their own. So sometimes you'll be asked to draw an illustration of these numbers. Okay? You'll be asked to draw an illustration of these numbers because they actually um, they actually subsets of each other. Okay, so this irrational is on its own, but actually it's a subset of the complex. Okay, so sometimes you'll be asked to draw this on a diagram. So let me draw it on a diagram. You see how it's going to look like. So if I want to draw all the types of numbers that are there. Okay, so now let's talk about the hierarchy of these numbers. Okay, so we're going to have the big set here, which is going to be for the complex numbers. Okay, so this one represents the complex numbers. Then from the complex numbers, we're going to have another big set of the real numbers like that. So this one here will represent the real numbers. And then in these real numbers, okay, in these real numbers, we're going to have the rational and the irrational part. Okay, we're going to have the rational and the irrational part. So the rational takes up much of the space like that. So here I'm going to put the rational, and then the irrational will just be somewhere there. So these will be the irrational numbers here. Okay, so let me put nicely there. So I, then R. So this is irrational, this is rational. And then the rational numbers are going to be divided into they're going to be divided into the integers. Okay, so we have the integers here, which are just Z. Okay, and then the Z, we have the whole numbers, which are just W. Then from the whole numbers, we have the what? The natural numbers. Yeah, so this is the hierarchy of the what? Of the sets of numbers. So the largest is the complex, and then you have the real numbers. The real numbers will be divided into the rational and the irrational. And then these irrational numbers will be divided into the integers, the whole numbers, and then the what? The counting numbers. Okay. And then under complex again, somewhere here we're going to have the imaginary numbers like that. So I for imaginary number. Okay, meaning that the complex number is made up of the real and the imaginary number like that. Okay, so this is the hierarchy of the sets of what? Sets of numbers. All right, so this question says, example 1.01, let the universal set U be a set of real numbers there. So meaning that our universal set U is actually from minus infinity all the way to positive infinity because they've said real numbers. Okay, and then let's set A be equals to 0 all the way to 6. Set B, let it be from minus 2 to positive infinity. So sometimes positive infinity, they won't include the positive there, just like all positive numbers. Okay, they'll just write infinity. C has been given as minus 3 and then 4. Okay, and then find the following sets and display them on the real number line. Okay, all right. So the first one here, they've said we should do find A intersection C. Okay, so the question is find the following sets and display them on the number line. But in answering such question, we'll start with the second part. We'll first display it on the number line and then find the set. Okay, that's how you answer such questions. So I'm just going to draw a number line here, a very simple number line like this. Okay, so that's my number line. And then I'm going to take note of the numbers that are in these intervals here. So there's A intersection C. So for A, if I come here, it's starting at 0 and then it's ending at 6. Okay, that's my interval for A. So make sure that you indicate the universal set, meaning you're starting from minus infinity all the way to positive infinity there. Okay, and then okay, so here you can draw an open circle like that if you want, but if you want, don't draw it. It's one and the same thing. So my set A is 0 to 6, and then my set C, it's minus 3 to 4. So minus 3 should be before the 0, right? So it's somewhere there, and then the 4 should be between 0 and 6. So I'll just write 4 there. Right, and then from here, I'll just draw a line to indicate set A. So set A starts from 0 all the way to what? To 6. Okay, so now is the 0 included in this interval? The answer is yes, because there's a square bracket there. So I'll shade this part like this. Okay, is the 6 included? The answer is yes, because there's a square bracket again. So I'll shade here. So I'll indicate this part here as my set what? A. Then let's shade set C. So C, it's starting at minus 3 all the way to what? To 4. So I'll put it on top somewhere there. Okay, and then I ask myself, is the minus 3 included? No, because here there's a curved bracket like that. So I'm going to put an open circle there on 3. Is the 4 included? Yes, because there's a square bracket. So here I'm going to put a shaded circle like that. So this is my set C. Okay, so now I'm finding the intersection of A and C. So meaning I'm just looking at the point where A and C are actually overlapping each other. Okay, where one line is on top of the other. So we see that that part will just be starting from here, okay, where I've shaded there, all the way up to there. Okay, so where it's starting here is starting at 0. Where it's ending here is it's ending at 4. So this is the intersection there. Okay, so meaning that my A intersection C will actually be equals to 0, 4. And then now I look for the type of bracket that I'm going to put here and there. So when I come at 0 here, 0 is included in A because it's shaded here. Okay, and this 0 is also included in C because at 0 there's a solid line that is passing over this 0. There's a solid line like that. You can see this line, right? So meaning 0 is also part of the C. So it's part of both A and C. So it means here 0 will be part in the what? Will be part of the intersection. So we put a square bracket. And then when I go at 4 again, when I look at part A, okay, a solid line is passing through 4 here. So meaning 4 is actually part of the set A. And then at the end point of C, it's shaded and the 4 is also part of that. So meaning that 4 is both in A and C. So I'll put a square bracket like that. It's in both of the sets. Okay, so meaning that this one here is my intersection of A and what? And C. So let's me even write it here. All right, so that's the answer there, our first answer. So any questions there? Any questions? Okay, so let's look at B. So B is the simplest here because they are saying B intersection U, and U is the universal set. Okay, so when you get any set and then you intersect it with the universal set, the answer is always going to be that same set. Okay, I hope you've gotten that point. When you get any set, you intersect it with the universal set, the answer is going to be that same set. So I'll draw a picture to illustrate. So if this is my universal set, okay, universal set, it means it's a set that contains all the sets that have been given, right? And then inside here, there's also another cassette B, okay? So now if they tell me intersect B with the universal set. So what is common between this universal set and the set itself B? It will just be the same B, okay? So B or any set intersecting its universal set is always going to be that same set, okay? So for us to answer this B here, the universal set we've already drawn it is from minus infinity to positive infinity. So for us to show the B intersection universal set, this is what I'm going to do. I'm just going to shade the part for the set B. So set B starts at minus 2. So minus 2 should be, I should have a minus 2 somewhere there between the minus 3 and 0. Then it goes to positive infinity. Okay, so it will start at minus 2 here, all the way to positive infinity like that. So we said positive infinity, you can never include it in an interval, okay, because it's not a number. It just shows you that the number is still going. So here I'll put an open circle. Okay, in fact, not even that, but just looking at the type of bracket that is there. This is curved, so meaning this thing is not included. So I put an open circle. On the minus 2 again, you can see there's a curved, so I'll put an open circle as well there. Okay, so this part here is my set B. So I'll just shade it if I want to represent it on the number line like this. Okay, and then this part B will just be the same set. So minus 2 all the way to what? Positive infinity. That is B intersection U. So any questions there on how we've done that? Okay, so if there are no questions, we move to the next one, which is part C. I don't want to erase the sets there. Okay, yeah. So let's look at part C. So part C has been given as C, and then you can see this like kakoma like that. Like that. So you've seen this kakoma here. It's not there for decorations, no? This comma means complement. Okay? And complement has a meaning. So when they write a set as C complement, they just mean all the elements that are not part of this set. Okay? You can see C is from minus 3 to 4. So meaning all the elements that are not here, they will be part of what? C complement. So this one is read as C complement. So they have given us C complement intersection A intersection B. Okay, so since here there's an intersection, there intersection, we're just looking at the part where the line for the C complement, the line for the A and the line for the B are going to be, they're going to be overlapping, like they'll be on top of each other like that. That's the part where we're looking for. Okay, so let's draw this thing on the number line first of all. So I'll start with the C complement. I show you how to draw the complement on the number line. So this is my number line here. Okay. So when I look at the values of C here, that's starting at minus 3, 4, 2 is minus 2, B is minus 2, infinity, A is 0, 6. So I'll say, okay, my minus 3 should be somewhere there. Okay, so minus 3, minus 2. Just write the numbers that you can see here. I have 0, okay, and then somewhere there will be a 4. and then a 6, and then positive infinity, here minus infinity. That's all, because you're dealing with intervals. Okay, so let's first of all plot the set C. C is from -3 all the way to what? 4. So at 3, there's a curved bracket, so I'll put an open circle. At 4, there's a square bracket, so I'll put a shaded like this one here. Okay, so this part that I've drawn here is my set C. Okay, but in the question, we are not interested in C. Okay, in the question, we're interested in what? C complement. So how do I find the C complement? I go at the end points of this set C. Okay, I go at the end point of this set C. So one end point is this 4 here. So this 4 here is included in the set C. Okay, meaning that in the C complement, the 4 is not going to be there. So how do I represent that? I'm just going to draw an open circle on top of this 4, and then I'll go this side. Okay, let me create a line. I'll go this side to the infinity like that. Okay, so at the end here, you can just put an arrow if you want, or you can put an open circle. It's the same. Okay, so this part that I've drawn is the first part of my C complement, because all the elements that are at this side, they are not part of C. So they are in the complement of C, or they are outside of the set C. Okay, and then again, I go to the end point of C on this side. I take a look at the 3, the -3 there. So the -3 is not a part of C, because there's an open circle on -3 there, like we discussed. So it means this -3, it will be present in the what? In the C complement. So I'll just shade on top here, and then I'll go to the what? To the left side here to meet the what? The -C complement, like that. If you want, you can just put an open circle here. Okay, so this one here will be the second part of the C complement. So this part here is what students, most students, they fail to do. Okay, they'll just write one complement and then they'll forget. No, if a set is within the universal set, then it will have two parts of the complement. Okay, there will be this side and then this side. So you can see I've written both sides of the complement of C, right? Okay, so we are done with the C complement. We know it to be here and there. Let's plot A. So A is going to start from 0 to 6. Okay, so I'll just put it on top here. So it's starting here at 0 all the way to 6, like that. And you can see that there are square brackets there, so we are shading both ends. So I shade this part, and then I also shade this part. So this part that I've shaded in black, it is my set A. Okay, what are we remaining with? We're remaining with the set B. So B, I'll write it on top again. It's from -2 to infinity. So it's starting at -2 there all the way to infinity. Okay, so at -2, I'm going to draw an open circle, and then here just an arrow or an open circle. It's the same. So this is my part B. Okay, so now the question that we want to find, or the region where we want to find, is where the C complement is intersecting the A and the B. Okay, so we're just looking at the point where the 3 lines are overlapping each other, like they're on top of each other. So anyone who can help us there, at which point are they all overlapping? From which number to which number? Anyone? At which point are they overlapping? From which number to which number? Come on, guys. Mzanube Saudesi.
Hello.
Yes, yes, yes.
Yeah. Okay. Perhaps just clarity on the question. What we are looking for intersection of is it A and B, right?
A, B, C complement. So 3 things.
A, B, C complement. Meaning where A is overlapping with B,
And also
as well as
overlapping
the
C
C
complement.
complement.
Yes, yes, yes.
Okay,
So which part there?
just so.
From which number to which number?
Ah,
You can see it, guys. It's
okay.
there.
um, Let me think what is others.
Can I try?
Yes, you can try.
I think from 4 to 6.
Exactly. Okay. From 4 to 6, you can see this is 4 here. Okay. You can see there's a part of this line, though it's not included in this C complement, but it's a part of it. There's a part of the black line and there's a part of the red line. As well as this side, we have on 6 here, we have the blue for the C complement, the black, and then as well as the red. So that we are the region that we are looking for, it will be this region here. Let me shade it to be which one? This region here, starting from here all the way up to there. Okay, so that's the region that we are looking for. Okay, so that will be the intersection of the C complement, the A, and the B. Okay, so I'm just going to write that C complement. Hey, what's happening to my pen? So C complement intersection A intersection B is going to be equals to, I've seen that, okay, the answer is between 4 and 6. So now let me determine the type of brackets that I'm going to put. So I'll start at this 4 here, okay? So is the 4 part of the C complement? The answer is no, because you see on the C complement there, on the 4 we had an open circle, okay? Is the 4 part of the A? Yes, because the solid line is passing through the 4 in black. Is it part of the B? Yes, again, because the solid line is passing there in red. Okay. So the 4 is in B, is in A, but it's not in C complement. So it cannot be in the intersection of these three. Okay. So it means the bracket that we're going to put here is a curved bracket because it's not in all these three sets. Okay. I hope you've understood that. And then we look at the other endpoint there again. This 6, okay, is it there in the C complement? Yes, because this blue line of the C complement here, there's just a solid line that is passing at 6 here. Okay, as it's coming from there, it's passing at 6 in solid line form. So meaning the 6 is here. Okay, is it there in A? Yes, because there's this shaded thing here in black. So meaning that it's there in A. Is it there in B? Yes, because there's a solid line again passing at this 6. Okay, so it means this 6 is in C complement, it's in A, and it's in B. So I'm going to put a what? A curved like that. So that would be our answer there. So our answer there would just be curved 4, and then 6, and then square bracket like that. Okay, as easy as that. So any questions there? Any questions there? Okay, so if there are no
On the
questions, oh, someone has a question?
on the brackets there, I don't understand why you're including the 6 and excluding the 4.
Okay. Were you there when we started the class? Hello? Okay, anyway. So we said that the curved bracket, okay, means that something is not included, right? As the end point. And then the square bracket, it means that something is included. Okay. So now when you go at 4 here, okay, remember the sets that we are trying to intersect is C complement intersecting the A and then intersecting the B. Okay? So if a certain element is to be in this set, then it has to be in C complement, it has to be in A, and it has to be in what? In B. Because intersection means something that is common. So now when I go to the C complement, remember this C complement here started at this point here where we said we have an open circle there. So this open circle here simply means this 4 here is not in the C complement. Okay, but is the 4 there in A? Yes. Is the 4 there in B? Yes. Okay, but for something to be in this set, to be considered a part of this set, okay, it has to be common in all the three sets. But this 4 is just in A and B, and it's not in the C complement. No wonder we're putting a curved bracket like that. I don't know if it's making sense, the one who asked. Okay, and then when you go to the 6, when you look at the 6 here, it's included in the C complement because the C complement has this solid line here, this blue one. So it's passing at this 6 from the left as it goes to the right. It's passing at this 6 as a solid line like that. So meaning the 6 is there in this line. Okay. Is it there in A? Yes, because this part here is shaded in A. So the 6 is there. Is it there in B? Yes, because there's a solid line that is passing there. So the 6 is in C complement, it's in A, and it's also in B. No wonder here we're saying square bracket like that. Okay, so is that clear? The one who asked the question. Hey, you're not responding. Okay, I don't know what has happened to her. Yeah, but I hope you've understood why we're including the 6 and not including the 4. Okay. Yeah, so that's basically that's how we can represent these things on the number line. Okay, that's basically how we can represent these things on the number line. And then the last question, I think I'll leave it for you guys to try it out. So you can try it out and then you can send the answers to my inbox. So this is the last question here. Okay, try to find C minus B union C. So the hint that I'll give you here is just the meaning of this minus. Okay, so if I have A minus B in set C, it's the same as A intersecting B complement. Okay, so this minus B, this part here, is the same as intersecting and then B complement. Okay, so meaning there I have C minus B union C, right? So this part minus B union C is the same as C intersecting and then B union C complement. So I want you guys to shed this set, okay, on the number line, and then actually find the values that are going to be contained in it. Okay, so that would act as your assignment for now. So just screenshot the question and then you can attempt it later, and then you send me the solutions. Okay, it will be your weekend assignment to do. All right, so I think that is the end for today's class. Unless you guys have any other question that you want to ask. Any other question, like how do we do things at Discrete Learning Institute? You can ask. You're free to ask.
So sorry, you were breaking at some point as you were explaining the question, the assignment.
Oh,
Personally, I wasn't
okay.
able to get you at some point.
I'll share the recorded video, but I was simply saying the meaning of the minus. So if you have A minus B, this minus B is the same as intersecting B, but now putting a complement there. That's what I was saying there.
Okay.
Yes. All right, but I'll share the video. You can watch the part that you missed. Okay. All right, okay. So if there are no questions,
All right.
let me show you something. Okay. So we actually have a website and a mobile app that has lessons on everything that you're going to learn. Okay. Everything, all these that I was teaching today, I've already taught them before. So there's the app and the website that actually can help you with whatever you want. Okay, you can be learning using it at your own time, at your own pace. Okay, so in fact, there's this tutorial sheet because okay, so yeah, there's this tutorial sheet for those who are at Unilus. This is tutorial sheet 1, and I must mention that Mr. Chipoka. Okay, Mr. Chipoka likes bringing questions from the tutorial sheets. So if you don't solve the tutorial sheets, you might end up failing the tests or the quizzes or whatever will be given you. So make sure you go through the tutorial sheet, solve every question. Okay, don't leave out any questions. Solve all the questions, and then also pass through the past papers, like uh, the tests, the quizzes, the exams that the previous intakes actually had. Okay, pass through them. So as you can see, this tutorial sheet here. on our website, we've actually solved and explained everything that you can see here. This tutorial sheet has about 7 questions and it has already been solved and the videos are there. So you can learn all these concepts that you can see here at your own time, at your own pace. You can see how to simplify whatever SADs. We'll also learn them for those who will be registered with us. We'll learn them like during the live lessons like this one, okay? And we'll also be providing the videos to the tutorial sheets, the past papers like this one. So this past, this is what now? This is a tutorial sheet, right? It has been solved. All these questions that you can see here have been solved and the videos are available on our website. You can actually just subscribe and then you'll be able to access them. Okay, so our lessons are 150 per course per month. Okay, so just pay 150. You are going to access and learn a lot. Okay, in your own free time. So it's not just math, even physics, we are doing the same. Chemistry, biology will be doing the same. Okay, so make sure you register with us. And then for those who do not know the website, let me show you. So you just go to Chrome here and then you search discretelearning.com and then you go to the website. If you don't have an account, you just create one. So when you come here, you're going to see the courses that we offer there. So math, chemistry, physics, biology. So for example, if I open this math course, there are different folders here. So if you're from Unilus, there's semester 1 and semester 2 here. If you're from Apex, there's semester 1 and semester 2 again there. So depending on the semester where you are, you go in that folder. So if I go in, for example, Unilus, right? I'm going to find the topic lessons here, summarize notes, the tutorial sheets. So if I go in the tutorial sheets, you're going to see the tutorial sheet is going to be there, like that the one I was telling you. So video solutions, you go there, you open the folder. There's 2026 January intake here. Okay. Open this folder for 2026 January intake. You're going to find tutorial sheet 1 algebra. So everything has been solved and the videos are there just waiting for you. So you can open this folder and then you actually what? Find the videos here. So question 1 all the way up to question 7. Okay. So it doesn't matter if you're from Apex, again, those guys have not opened yet, but when they open, all the tutorial sheets, even for them, we're going to be solving and we're going to be uploading them there. Okay, so if you need extra help, don't hesitate to join the Discrete Learning Institute. We are here to help you and actually to guide you guys. All right, so before I close the class, any question that you have? Any question? There's also this assignment if you want to try it out. This is a question from the tutorial sheet. You can try it out. Any question? All right, if there are no questions, have a blessed night, guys, and all the best in your academic journey for this year. I wish you all the best.